In this video, we're going to go ahead and put together our projectiles. So you'll see that we already have a projectile, a pathed projectile is what I called it, that's being shot out of our cannons. But I want to create a generalized concept of a projectile that can be used for both our player as well as our enemy. These projectiles will have a couple bits of functionality. First of all, they will always take in a initial velocity, a owner, whichever game object spawned them, and a direction, which is going to be what direction they're going to be shot in. Then they're going to have different behaviors based on what they collide with. So if a projectile collides with something that implements a special interface that we're going to write called I take damage, then we want to apply a certain amount of damage to that object. Or if the projectile hits something like a piece of the level, we want that projectile to just stop. Or if the player hits something like a star, we want it to keep on going because certain objects in our level we want to mark as being able to be passed through by the projectiles themselves. So what I want to do is I want to generalize the concept of a projectile so that we can create a variety of different kinds of projectiles. However, we will only be creating one projectile type that will be shared by both the player and the enemy in this series, and we'll create two different prefabs based off of that. But I definitely want to make a general concept of a projectile so that maybe in the future, if a person wants to create a projectile that behaves slightly differently, they can do so. So I want to abstract the most common bits of logic of a projectile into one abstract class that will be a mono behavior, and then I'll create a child class that adds some additional behavior to that, such as what happens when a projectile hits X thing, where X could be a thing that is capable of taking damage, or a set piece, or the owner of the projectile, and so on and so on. In addition, I want the projectiles that get shot out from the enemy be able to be destroyed by the player, and the player to be able to receive points based off that projectile being destroyed. So we'll have to code that logic in there too. So let's go ahead and start by creating the base projectile class. I'm going to go ahead and jump into Visual Studio. I'm going to come up here to my code folder, and I'm going to create a new class called projectile. I'm going to hit enter. I'll remove the namespace definition, and I will have this inherit from mono behavior. In addition, I'm going to mark this class as abstract. So what we're seeing here is an example of an abstract mono behavior. This technique is very useful for a variety of circumstances. Particularly, it's very nice because we can have a player have a public field of type projectile, and we'll be able to fill it in with any prefab that has a component on it that inherits from this class, which will guarantee the existence of certain functionality. So it's a very, very nice technique. You'll notice if you're not familiar with the abstract keyword, what we're doing here is we're marking the base projectile class as non-instantiatable, meaning you won't be able to add a projectile class to anything or instantiate it in any way, but you will be able to instantiate children of this class, given that those children are non-abstract. So the abstract keyword just gives us the ability to mark a class as a base type, in that we intend for this class to only be used as a parent for other classes that will be used by direct instantiation or by instantiation by Unity. All right, let's go ahead and stub this class out, or not stub it out, but let's just go ahead and implement it. It's not very big. We're going to have a couple public fields on it. We're going to have a public float speed on it, and then we're going to have a public layer mask collision mask. Then we're going to have a few public properties. We're going to have a public game object owner property with a getter, public getter, and a private setter. We'll have a public to vector or public vector to direction property with a public getter and a private setter. And then we'll have a public vector to initial velocity, which will mark the velocity of the owner when he fired this projectile. So we want to add the initial velocity to our speed when we perform our logic. In this case, we're probably only going to be using the x component of the initial velocity, but We won't worry about using the y component. So if a player jumps, the projectiles will continue to go to the right while he's jumping, as opposed to going diagonally. Of course, the behavior that we'll be using for moving the projectile is going to be something that we implement in a child class and not in the parent class, meaning that if we did want to make projectiles that move diagonally, we could do so simply by subclassing this parent class. Now we have something else that important that we need to add, and that is our public void initialize. The initialize will take in a game object, owner, a vector2 direction, and a vector2 initial velocity. And these parameters will simply be set to our public properties. So owner equals owner, direction equals direction, initial velocity equals initial velocity. So why are we adding an initialize method? Well, remember in Unity, our mono behaviors can't have constructors. So in order to pass data from the owner, or from the person who instantiates this object, to this object, we need to use something like an initialize method. And that's a common term that I will use for any method that does take in what would normally be taken in by a class constructor. Finally, I want to invoke a method at the end of initialize. I want to invoke on initialized. On initialized. I'm pretty sure that's what we want there. You'll notice that this method doesn't quite exist yet, and I am missing an A in there. I hate spelling. Why don't I have a spell checker? Yeah. I-N-I-T-I-A-L-I-Z-E-D. There we go. Okay, so our onInitialized method will be invoked by our initialize method when that is invoked by the person who instantiates this particular game object. The onInitialized method will be a protected virtual onInitialized, and it'll be void. I forgot the return type in there. And it'll be empty. So what am I doing here? Well, first of all, I'm marking this method as protected, meaning it's only accessible from this class and his children. Then I'm marking this method as virtual, meaning it's overridable by the children. Then I'm making it void, and I'm calling it onInitialize, and I'm leaving it empty. That's because I want to make this an optional method that the child classes can implement if they choose to, but are not required to do so. And this method will be invoked after our initialization. Okay, there's really going to be only one method with logic in here, and that's going to be a public virtual void on trigger enter 2D method that takes in a collider 2D other. And this method will have an implementation in it. And the implementation is going to A, check to see if the thing we collided with matches the collision mask. Then B, it'll invoke a variety of different protected virtual void methods that we will be adding into this class. So basically, we're kind of abstracting the logic for the different scenarios in which this projectile will collide with another object. There are 4 different scenarios. Either this projectile will collide with something that does not match our collision mask, or this projectile will collide with the owner of this projectile, or this projectile will collide with something that is capable of receiving damage, or this projectile will collide into none of the above. So let's go ahead and put that logic together. First of all, I'm going to say if collision mask dot value, and I have to add in some parentheses here, if collision mask dot value and then we're going to open up more parentheses. Notice that I used a single and not the multiple and 1 shift left other dot game object dot layer. If this equals 0, that means that we collided with something that doesn't match our collision mask. Now, after I finish this method and I've stubbed out our other methods, I will explain exactly what's going on here and why this logic works. But until then, let's just leave it as it is, and then I'll explain it later. We're going to say on not collide with, passing in other, and then we'll say return. Now, on not collide with is not a method that has been implemented yet, and we'll implement it here momentarily. Next up, I want to say var is owner equals other dot game object equals owner. If is owner, then on collide owner, and that's really all we need to do. So we'll say return. Then I'll say var take damage equals I take damage, which is an interface we have not implemented yet or not created yet. Other dot get component. Now this is important. We're not using the generic form of get component. We'll talk about why we don't do that here in a moment. Get component type of I take damage. If take damage does not equal null, then on collide take damage. And we'll also want to pass in other and take damage. We'll see why that is here momentarily. And then we'll say return. Finally, on other or on collide other. And the on collide other will simply return other. Okay, so let's go ahead and stub out these methods. These methods all will be protected virtual methods with empty bodies, meaning it'll be optional for the projectile children to implement or override these particular implementations. So let's go ahead and write those. I'm going to say protected virtual void on not collide with collider 2D other. Then I'm going to say protected virtual void on collide owner, and it'll be empty. Protected virtual void on collide take damage, which takes in an I take damage other. And then we'll do, or of course, the on collide take damage takes in the I take damage other, as well as the collider 2D other, which I kind of combine these two. And we're going to have to rename this parameter so it doesn't conflict with our other parameter, and we'll call this parameter take damage. Then we want our protected virtual void on collide other, collider 2D other. Okay, so at a high level, what is going on here? Well, we're implementing an onTrigger inter 2D method that will be invoked with Unity when this collider hits another trigger. Then we're checking to see if the object we collided with matches our collision mask. If it doesn't, it'll invoke the on collide with other, or on not collide with passing in the other thing that we collided with. The on not collide with method is protected virtual, meaning it is an optional thing that our children classes can choose to implement if they wanted to add behavior in the case that we collided with something that doesn't match our collision mask. Next up, we check to see if the thing we collided with is our owner. If we do on collide owner, which again is an optional method that our children classes can override if they want to. Next up, we try to extract out the I take damage interface from the thing that we just hit. If that was successful, we invoke the on collide take damage method, which again is an optional method that can be implemented by our children. And if none of these things happen, then we invoke the on collide other method, which means that it was a thing that we should collide with, it wasn't the owner, and it doesn't implement the I take damage interface. Again, this allows us to implement any or all of these methods in our children classes to extend the functionality of our projectile. Let's talk a little bit about the I take damage, and then we'll talk about our collision mask. The I take damage interface we'll be writing here momentarily, and it is an interface that we can implement in our mono behaviors that tells or instructs other bits of code that that object is capable of receiving damage. You'll notice that in our check right here, what we do is we try to extract out the I take damage interface from the other's components. Now you'll notice that we do not do this. We do not say other.get component of I take damage. The reason we don't do that is that generic overload of get component requires the generic parameter we pass into it to be an object that inherits from UnityEngine.object, the base Unity object class. Well, the thing is because I take damage is going to be an interface, that's impossible. Because that's impossible, we have to use the non-generic form of getComponent. And by using the non-generic form of getComponent, we'll have to do two things. First of all, we have to pass in the type of the interface we want to retrieve via the type of operator. And then we have to cast the return of getComponent, which is of type component, into that interface that we were expecting. So by doing that, we are able to retrieve that interface. Now, of course, it's red because we haven't created the iTakeDamage interface yet, but we will. Okay, let's talk a little bit about our collision mask and why this works. So what is the collision mask? What is the .value, and what is the layer? So as you'll notice, if we jump into Unity, if we come up here to layers and hit edit layers, you'll see that we have layers from built-in layer 0 all the way to layer 31. We have 32 total layers that we can play with, from layer 0 all the way to layer 31. So let's go ahead and let's just assume that we can only have 8 layers, from layer 0 to layer 7. Let's just say that that's all the layers we can have for the purposes of me demonstrating why that bit of bitwise logic works. So let's come back into Visual Studio, and I'm just going to write some comments up here. You guys don't have to obviously write these comments because they're comments and they're ignored by the compiler. And I just want to demonstrate some bit of binary arithmetic. So we have layer 0, layer 1, layer 2, layer 3, layer 4, layer 5. Maybe I should have only done 4 layers. Layer 6, layer 7, layer 8. So these are our 8 layers that we're saying that we can have. Of course, Unity supports 32 layers. Or sorry, we don't have a layer 8. We have layer 0 through layer 7. In Unity, we have 32 layers, but that would just require so many of these things that it would just be impractical to show you guys. So what is the binary representation of layer 0 in binary? That was redundant, but what is the binary representation of something like layer 0? Well, the binary representation is going to be 0, 0, 0, 0, 0, 0, 0. So it's going to be 8 zeros. Because again, we're just working with a single byte of information, whereas in Unity we have 4 total bytes of information to work with. Or not 4 total bytes, but yes, 4 total bytes. So then layer 1 is going to be 1. Layer 2 is going to be 0, 0, 1, 0, like that. Layer 3 is going to be 0, 1, 0, 0. Layer 4 is going to be that. Layer 5 is going to be that. Layer 6 is going to be that. Layer 7 is going to be that, and I messed up somewhere. 0, 1, 2, 4, 8, 16, 32, 64. Yeah, I did mess up somewhere, but it's okay. Because I simply forgot that layer 0 will actually have a binary value of 1 because I am a terrible person. So let's go ahead and fix this. Derp. Obviously you can't have a layer that's represented as all zeros, and you'll see why that's obvious here in a moment when we talk about how our layer masks actually work. The important thing here, though, is by having 8 bits worth of information, 8 ones or zeros, we can uniquely identify all of these layers. And so this is what all these layers will look like in binary. So let's go ahead and talk about what the decimal values of the binary representation would be. Layer 1 would be 1, layer 2 would be 2, layer 3 would be 4, layer 5 would be 8, layer 6 would be 16, or 4 would be 16, layer 5 would be 32, layer 6 would be 64, and layer 7 would be 128. So those are our 1, 2, 4, 8. So those are our decimal representations of the binary representation of each one of our individual layer numbers. So again, this is our layer number, this is our binary, and this is our decimal value. So what does our layer mask look like? So now we need to define two things in order to understand this expression. First of all, what is our collision mask? What is the dot value? And what is the other dot game object dot layer? Well, the other dot game object dot layer is actually this number right here. It's the layer number. It's important to understand that the other dot game object dot layer is not the decimal representation or the binary representation of that layer number. It is the layer number itself. So that's why it's important to understand this code, or what the layer actually represents. It's an integer from 0 to 32. So it goes from 0 all the way, or sorry, 0 to 31. Let's talk about the layer mask dot value. What's the layer mask dot value? The layer mask dot value is the binary representation of combining multiple binary representations of each one of these layers. So let's say our layer mask was layer 6 and layer 3. Now remember, we can name these layers whatever we want in the Unity editor, but at the end of the day, they are really just going to be layer 0 through layer 7. But we can name them whatever we want arbitrarily, but that doesn't matter to Unity because Unity will just work with the numbers. So if we wanted to combine layer 2 and layer 5, for example, to create a layer mask that only applies to objects on layer 2 and on layer 5, what binary representation would we get? We would get 0010 plus 0100. So this would be our 8 bits. Notice that I am adding a space between each 4 bits. This number could also be represented without the space. I add the space for a little bit of clarity. So let's say we want to combine layer 1, layer 4, and layer 7, layer 6. So layer 1 would be, or let's start backwards. Let's say layer 6 would be 01, layer 5 would be 001, and then we would want layer 2, which is 01, and then layer 1, or layer 1. I know so 01 and then 10. So this would be our layer 1, our layer 2, and our layer 6, and our layer 5, represented as a single byte, whereas a byte is 8 bits, of information. So you can see with this scheme, we can uniquely reference a unique combination of every single one of our layers using simple binary arithmetic. So the question is, how do I get from a mask? Let's say our layer mask equals this. So let's say layer mask equals this bit, or this byte. And then let's say we want to compare it with a layer in, let's say layer 5. So we want to know if layer 5 is layer 5 in the mask. So we want to know that question. That's the question we're asking right here. So is layer 5, which is going to be this value right here, in the mask, which is going to be this value right here? How do we do that? First of all, we need to turn the concept of layer 5 into its binary representation. So we need to say, okay, so layer 5, we see that its binary representation is this right here, but we need to turn it into that. We need to turn the number 5 into this number. We need to turn the number 5 into 32. What's the easiest way to turn the number 5 into 32? Well, we can do 1 left shift 5 equals 32. How do we know that? Well, the left shift operator will take the bits in a number and shift it left X amount of times, in this case 5 amount of times. So if we had the number 1 in binary, which is 0000001, that's 1, and we shifted it 5 times, what do we get? Well, we get, if we shift this 1 5 times, so that's going to be 1, 2, 3, 4, 5, we're going to get 00100000. Remember, so that's shifting it once, twice, 3 times, 4 times, and then 5 times. We'll push it all the way to this number right here. You'll notice that we have successfully converted this layer number, this layer index, into a binary representation that is compatible with our layer mask. So now that we have our number 32, how do we see if 32 is in this mask? Well, we can do the AND operator. So if I take 0, 1, 1, 0, 0, 1, 1, 0, which is our layer mask, and then I take 0, 0, 1, 0, 0, 0, 0, 0, which is our layer, individual layer, and I AND them. So let's go ahead and insert an AND right here. This is the bitwise AND. If I perform this operation, what number do I get back? I get back 0, 0, 1, 0, 0, 0, 0, 0. Why? Well, the AND will only return a 1 on each column if both bits are set. So the only way that it returns a 1 is when the 1 is set and the 1 is set here, which means this object is indeed in the layer mask. How do I know that? Because this does not equal 0. Let's do one more example. Remember, this layer mask is going to equal 5 and 6 and 1 and 2. Let's try to see if the layer 7 would work. Well, if this was 7, that means we would take 1 and we would shift it left 7 times and get this binary representation. So we take the layer mask 0, 1, 1, 0, 0, 1, 1, 0. We AND it. And then we AND it to 1, 0, 0, 0, 0, 0. And we get 0, 0, 0, 0, 0, 0, 0, 0, which this in binary is equal to decimal 0. Meaning that it will return 0 because it's not in the mask, and we will invoke not collide with other. Okay, so that's how this code works, and that's why this code isn't as scary as it looks. The only other thing that makes this code a little bit scary is all of the parentheses, and that's just because of the order of operations between equality, left shift, and AND. I definitely want, whenever you're working with binary operators, such as the AND or AND or the exclusive or whatever, always make sure to parenthesize the stuff because the order of operations may conflict with the other operators that you might be using, which would cause unexpected results. But anyway, now that I've been talking about binary for the last 10 minutes so that we can talk about how Unity works with layers and how exactly layer masks work, let's go ahead and move on and actually create the child class that we're going to use for our projectile, for both our player projectiles and our enemy projectiles. So I'm going to go ahead and delete all this code, or not code, these comments. And then I'm going to go ahead and start with the I take damage interface. So that's the one bit of code, or one bit that we're missing inside of the projectile class to make it compile. So let's come up here to our code folder, and let's add a new interface called I take damage. We're going to remove the namespace definition. The I take damage interface will simply say void take damage int damage game object instigator. And of course, by using game object, we have to bring in using Unity Engine at the top. So void take damage instigator. What this does is any mono behavior that implements this interface will be picked up by our projectile, and the proper method will be invoked, the onCollide take damage method. So for example, our player will implement this interface, and our projectiles will also implement this interface because projectiles can be destroyed by other projectiles. In addition, our pathed projectile will also implement this interface so that they can be destroyed by player projectiles as well. Okay, you'll notice one thing if you have ReSharper installed, if you go back to your projectile.cs file, and that is we now have a warning. It says suspicious cast. There is no type in the solution that is inherited from both component and I take damage. That's because we haven't added any mono behaviors that implement I take damage yet. Once we do, that warning will go away, so don't worry about that warning. Alrighty, so now that we've done that, let's go ahead and work on our base, our actual child projectile class. So the actual class that's responsible for moving through the world, and then it's also going to be responsible for colliding or providing logic when it collides with other objects. So inside of code, I'm going to write a new class called simple projectile. Take off the namespace declaration or definition. Now he is going to inherit not from mono behavior, but from projectile. Now, of course, this indirectly causes this class to inherit from monoBehavior because projectile inherits from monoBehavior, as you can see, which means this class will indeed be possible to add to a game object. So that's exactly what we want. Okay, so we're going to need some public parameters that we can manipulate in the inspector window. We'll first need public int damage. That's how much damage this projectile will apply to an object if that object implements the iTakeDamage interface. Next up, we need to public float speed, and the speed is how fast the projectile is going to move, which we have already implemented in our parent class. I totally forgot about that. Sorry, guys. Thank God for ReSharper here telling me that we're hiding from the projectile. So that means just take off that definition. We are going to be using the base projectile speed instead. So we have damage. We will have public game object, and we'll have destroyed effect. And we need to, of course, bring in using Unity Engine at the top. We have public int points to give to player. So those are going to be the points to give to the player if it's the player that destroys a projectile. After we do our points to give to projectile or to player, and our destroyed effect and our damage, that's really all we need to worry about as far as public methods. So then we'll go ahead and write a private float. Let's actually do a public float in this one. I'm going to do a public float time to live. So I'll do another public property or another public parameter called time to live, which will be the maximum amount of time that the projectile can live without hitting anything before it automatically destroys itself. Okay, before we move on to writing our methods, I do want the simple projectile to implement iTakeDamage. So we will add a comma, iTakeDamage, and then we will implement the takeDamage method right here. So public void takeDamage int damage game object instigator. Now we will be implementing this method shortly. At the moment, we don't want to implement it. But I did want to, before I would forget, to implement the iTakeDamage method because again, projectiles can destroy other projectiles. Okay, let's go ahead and start with our update method. All the update method is going to do is it's going to move this projectile along the trajectory that was set by the owner of this projectile. In addition, it also has to check to see if the time to live has expired yet, because if the time to live has expired, we want to destroy this game object. So what I want to do with this in this case is I want to allow, actually no, I don't want to allow projectiles that have an infinite time to live. And the reason for that is because if a player manages to shoot off, I don't know, outside of the level for some reason, we eventually want that projectile to be cleaned up. So what I'm going to do is I'm going to say if time to live minus equals time.delta time is smaller or equal to 0, destroy projectile, and return. Now you'll notice that instead of invoking the Unity's destroy method and passing in the game object of the projectile, I'm invoking a method that I haven't written yet called destroy projectile. And I'll write that in here in a moment. The reason I'm doing that is because I want the destroy projectile method to instantiate the destroyed effect if it exists, but I don't want to repeat that logic everywhere in this class. So I'm going to be taking that logic of instantiating the destroyed effect and reusing it multiple times. And to do that, I need to turn it into a method. We'll write this method shortly. Now all that's left to do instead of my simple projectile is say transform.translate. And I want to translate on direction, then plus new vector 2 of initial velocity dot x, right, times speed times time dot delta time in the world space. So what am I doing? Well, every update I want to move this projectile in the direction that we're going plus the initial velocities x, which by the way I want to do initial velocity x comma 0 in this case. And then I want to scale it up by the speed of the projectile, then I want to scale it down by how many seconds have elapsed since the last frame. So that's why I'm using the time.delta time right there. So this will move the projectile along its direction. Okay, so next up, what I want to do is I want to go ahead and override a couple of these methods. Actually, really the only one that I want to worry about is onCollideOther and onCollideTakeDamage. OnCollideOther will happen, for example, when I hit a platform or something that's impenetrable. And in that case, I want to destroy the simple projectile. OnCollideTakeDamage, however, will happen when I hit something that's capable of taking damage. In that case, I want to add damage to the thing that I hit, based off the damage parameter of the simple projectile class. And then I also want to destroy the projectile. So let's come back here. And underneath take damage, I'm going to say protected override onCollideOther, which is, again, when I collide with something that's impenetrable. And I want to say destroy projectile, which again is a method I haven't implemented yet. Then I want to say protected override onCollideTakeDamage. Now the onCollideTakeDamage method will do two things. First of all, it'll say takeDamage.takeDamage, passing in the instigator and the total damage. The damage is going to be the damage parameter passed in, and the instigator is going to be our game object. Then I want to destroy the projectile. Okay, so that's onCollideOther, that's onCollideTakeDamage. Let's go ahead and implement our destroy projectile method, which will simply be private void destroy projectile. What we're going to want to do is say if destroyed effect does not equal null, instantiate destroyed effect transform position, transform rotation. Then I just want to do destroy game object. And that's really all I need to do with destroyed projectile. Okay, there's one more thing I have to do, and that's the take damage method. The take damage method will, not surprisingly, destroy the projectile. But in addition to that, it will also award points to the player if we have points to give to player set to anything other than 0, and our game object instigator is the player. So how do we know if the game object instigator is the player? Well, we can see a usage of take damage right here. We see that we pass in, if this projectile hits another projectile, it will invoke the take damage method on the other projectile, and it will pass in the game object that represents that projectile. However, that's not the player, because remember, we have to extract the projectile first so that we can get the projectile's owner. The projectile's owner will be the player, or it'll be the other AI that might have shot that projectile for whatever reason. So what we want to do on take damage is we first want to say something like if points to give player does not equal 0. Now, I'm saying not equal 0 instead of greater than 0 because this makes it possible to award negative points to player if they shoot this projectile, which I don't know if is a game mechanic that's even worth including, but, you know, it is possible now by just doing is not equal to 0 rather than is greater than 0. So if points to give to player does not equal 0, now we have to determine if the instigator that caused this take damage to occur is the player or is owned by the player. So what I'm going to do is I'm going to say var projectile equals instigator get component projectile. Then I'm going to say if projectile does not equal null and projectile dot owner dot get component player does not equal null, then game manager instance add points to give to player and floating text dot show string format plus placeholder explanation point passing in points to give. And then for the style, I'm just going to cheat and use my point star style, which is point star text, as opposed to creating yet another GUI style. Again, if you wanted to get a custom style for the for these points being added, you might be able to go into, or you would be able to go into your GUI skin and add a custom style here. And then for the floating text positioner, I'm going to pass in new from world point text positioner, passing in camera.main, transform.position, time to live of 1.5 seconds, and speed of 50 pixels up per second. So now, if the player shoots a projectile and it hits another projectile, and that projectile awards points, then it'll award those points when it takes damage. The last thing I want to do in take damage is say destroy projectile. Because once the projectile takes any amount of damage, I want it to be destroyed. Alrighty, so that is our simple projectile. Let's go ahead and do a couple of fun things. Or not a couple of fun things. Let's go ahead and leave the video here as it stands. In the next video, we'll go into the player and we'll actually write out the logic for shooting the projectile and so on. We'll actually go and create the prefabs that constitute the projectile as well. So we'll see you guys in the next video.